So elasticity connects with revenue. We went through a little bit of that last time. Total revenue is price multiplied by quantity. From the demand curve shown, for any price in the market, there's a certain number X demanded. When those are multiplied together, that's the area of the box, which I've shaded pink here. If a business sells 8 items at $30 each, then their revenue is $240. Simple enough. What's the connection with elasticity? Well, if I lower the price, what happens to revenue? If a business put on a sale, they lower the price. But is that good for business? A lower price means less revenue per unit sold. Lowering the price means the business is not going to get as much money on everything that they sell, but they will sell more units. Is that good or bad? Well, let's make these easy numbers for now. Business sells 100 Q at price equals $1, so revenue is 100. That's Q times P. If the business instead sets a price of 99 cents and sells Q equals 110, well, is that better or worse? Changing the price from $1 to 99 cents means they make a penny less on everything they sell. But they sell a whole bunch more than they make it up. Penny less on the 100 that's sold means a total of $1 less, but they sell 10 more at 99 cents each. That's $9.90 more. That's net good for business revenue. Is such a large effect plausible? Well, retailers know that consumers are kind of fooled that way. If we think about it for even a moment, we know in our minds there's only a penny difference, but sometimes we can be fooled. If they dropped the price to 98 cents and sold 111, was that next penny drop worthwhile? They lose a penny on 110 items, so revenue is down by $1.10. They sell one more item, so revenue is up by just 98 cents. So that's a net loss. So it all depends on how much the quantity changes when the price changes, which is just elasticity, exactly. Now note, one of the key assumptions I'm making is that this is a commodity. It's undistinguished and homogeneous, so the person selling it cannot charge a different price to different buyers. Now obviously businesses work really hard to try to set different prices for different buyers, such as websites that use your browsing history or even operating system to change the price they'll show you. There are astonishingly complicated algorithms behind trying to wring a few extra bucks out of each one of us. Going back to the graph, here's the same pink box of revenue, but now the businesses lower the price, so that's delta P off of the box. It got smaller by that vertical distance. However, the revenue box also got wider as more units are sold. So the net change to revenue depends on the relative sizes of delta P and delta A. I'm sorry, I meant Q. The change from the pink box to the green box is that the green box is shorter by that slice at the top, but wider by that slice on the side. The elasticity of the demand curve shows the relative size of those slices. If the demand curve were very steep, so there were not much of a change in the quantity, then the revenue would be shorter but not much wider, and that would be smaller on net. If the demand curve were flatter, then there would be a lot of change in quantity, so revenue would be shorter but a lot wider, and so grow on net. That's exactly what the formulas tell us. Total revenue, TR, is the price, P, times the quantity. With a bit of calculus, you can take the log of both sides, and then the derivative, remembering the derivative of the logarithm is the percent change. So the percent change in total revenue is the percent change in P plus the percent change in Q. That's a lot of mathematics, but it's actually useful in the world. Consider this sign I saw up in Maine. Sort of dollar store, not an official dollar store, that's a trademark name, but kinda. Anyway, apparently they had some problems. They weren't bringing enough revenue, so they tried to be a 50-cent store. You can see that price below. They dropped most prices in half. Do you think that generated a sufficient change in total? They'd have to sell twice as many items at half the price to just keep revenue the same? Spoiler, next time I drove by, the store was closed and there was a sign for rent. So, clearly not. I think that with a bit of reflection, you could have guessed that. For most consumers, there's not a huge difference between a price of $1 or a price of 50 cents. They're both pretty cheap. People might buy a little more at the lower price, but not twice as much. But economists love to use elasticity. We love it so much. We use it all the time. Humans in general are not really very smart. When we get a good idea, we're going to use the heck out of that good idea. So elasticity is a good idea. And we keep using lots of variations. So we've been talking about elasticity of demand, but there's also elasticity of supply. Instead of looking at changes along the demand curve, we look at changes along the supply curve. For example, olive oil prices rise. How much more olive oil will be produced? Now, obviously, that depends over time. In the short run, maybe not much more. In the long run, on the other hand, it might be more sensitive to price changes. We could define the cross-price elasticity. If coffee prices change, what happens to the quantity of donuts sold? We also talk often about income elasticity. If people have 1% more income, how much more do they spend on different items? Maybe wine. Often they're going to step up the quality purchased as well.